Hello everybody. Today I'd like to talk to you about high definition CCTV and H.264 in practice. So I'll be introducing you to the AD group of companies and the range of capabilities they have across a number of industries. Then we'll look at the benefits that high definition CCTV can actually provide. Then, what actually is H.264? Lots talked about it, but it certainly is not well understood as a topic. So we'll have an in-depth look at what H.264 actually is, and in particular H.264 profiles and the applications to which they can be put. Then we'll have a look at some of the obstacles to high-definition CCTV and how H.264 in certain circumstances can certainly mitigate some of those, particularly the areas of high bandwidth and high storage requirements. However, H.264 is by no means a panacea. It will meet certain applications very well, but in certain applications it provides very little benefit indeed. So we'll actually quantify some of the achievable data reductions that can be as a result of using H.264, and the need to use PCs, high-powered PCs, very often to actually store and decode, particularly when we have large camera counts involved. And also, with H.264, it means that the system that we end up with is not seamless with legacy CCTV, so we end up with separate technologies dealing with separate parts of the CCTV system. So we'll advocate a better approach, the NetView connected approach to high definition CCTV, and I'll talk in some detail about that later in the presentation. And here we have the companies that form the AD group. We have Dedicated Micros there, who are the world's #1 manufacturer of video servers and digital video recorders for surveillance applications. We have Detector Technologies, or DTEC, who are leaders in video smoke detection systems. Below that we have AD Aerospace, who are experts in airline CCTV and surveillance systems, and their products are type approved on many types of aircraft around the world. And below that we have Chipwrights, who are a fabless silicon foundry based in Boston in the United States, and they design and manufacture a range of visual signal processors that form the heart of many products within the AD group, but also in many other application areas as well, including things like IPTV, and so they have a very broad experience in the field of video compression technologies. So now let's look at what are the actual benefits that high definition CCTV can bring us. So first of all, having much higher levels of detail within the images, both for live and recorded images, gives us the ability to be able to identify people at greater distance from the camera, recognize those individuals. If the application is one of car number plate capture, then giving us more detail within the image allows us to actually give us much higher levels of accuracy in car number plate capture. Just for two examples. Also, if we are recording at very high resolution, then we can retrospectively zoom into those images on playback, and using intelligent interpolation algorithms, it gives us the ability to be able to extract far more detail out of those images than would be possible with mere analog PAL or NTSC resolution images. If we combine our high definition cameras with Panamorphic very wide angle lenses, so-called fisheye lenses, and we're able to de-warp those images to remove the spherical aberration that will occur, then we can actually use that technology, that combination of technologies, to provide much greater levels of surveillance coverage with fewer cameras. So we can always record everything and then use the retrospective zooming on those images and the de-warping algorithms to be able to review those images with a minimum camera count. Now let's have a look at high definition CCTV in action. Here we have an analog camera being recorded at 4CIF, and notice the level of detail that's being achieved here. Look at the edges of the characters, and also look particularly at the cover of the brochure and the level of detail that you see there. Comparing that to a megapixel image, this is a 2 megapixel image, and notice instantly the improved level of detail and the sharpness of edges. Also the cover of the brochure is quite legible even at this distance. Now let's use electronic zoom to look in a bit more detail. Starting with an analog camera, electronic zooming up to 200%, and we notice there the level of increased pixelation. At 400% the effect becomes worse. And of course up at 800% then we're noticing an awful lot of stretching of the edges. The brochure cover there is totally illegible. Doing the same on a megapixel image, however, notice there that there's very little picture degradation there, if any. The brochure is very legible. At 400%, again we're managing to extract more detail there. The edges do not degrade. And notice there as well how legible the brochure cover is at 800% zoom. So it's showing you there the level of detail within the image. Again, now let's go back to an analog image at 800%. And there's the megapixel. So we can clearly see there the improved level of detail that we have and how useful that can be in real-life CCTV applications. Using high-definition cameras with panamorphic lenses, those with very wide angles of view, 180 degrees or more, allows us to give us total surveillance coverage of an area, but minimizing the camera count to achieve that. The one camera with a fisheye lens can always record everything that occurs in that room, but we really do need the resolution, the high definition detail present with megapixel camera images for a practical solution. Analog cameras simply wouldn't have that amount of detail. And then to make the system truly usable, then we need to be able to de-warp the image. You'll see how the spherical aberration that's occurred within the top picture there makes the picture fairly unusable in real-life CCTV applications. So we need to apply de-warping, something that's on some solutions has been an expensive and add-on technology, but with certain solutions, particularly NetView Connected, then we can actually apply that de-warping for free, essentially, as it becomes part of the codec architecture provided by Chipwrights. So now let's summarize the case for high-definition CCTV. Yes, as we've seen there, then megapixel cameras can offer real benefits in terms of image quality, allowing us to be able to give a greater capability of identification and recognition of individuals, capture car number plates with higher accuracy. The images themselves, being very high definition, may therefore need large bandwidths to be able to store those images at full resolution, or to be able to view them, transmit them over a network and view them. Those high definition images may need to be highly compressed to make them more deployable, so we can actually store those images and we can actually view them remotely, either live or playback. H.264 is used in broadcast and consumer applications quite widely and is developing, and it can provide higher compression capability compared with other codecs such as JPEG, motion JPEG. And the popular misconception that arises from those statements is that megapixel images therefore must be compressed using H.264. What I want to go on to show you now is that that is certainly not the case. We can use H.264, but it certainly isn't a prerequisite for the successful deployment of megapixel images.